In topic 2, we look at the structure of an atom. We're going to start with looking at the protons and neutrons and electrons in a given atom. I'm sure you know by now that a proton is positively charged, an electron is negatively charged, and a neutron has a charge of 0. These are not in the real units of charge. These are just relative to one another. The charge of a proton and electron is the same, but opposite charges. In terms of mass, the mass of a proton and a neutron is about the same, and the mass of an electron is much smaller. So when we're generally computing the mass of an element, we don't consider the electrons and how they contribute to it because they contribute to it on such a small scale. But if I had something that had 6 protons in it and 6 neutrons and 6 electrons in it, and I wanted to add up the mass, I would only really need to include that. So we would say that the relative atomic mass would be 12. A sub r is what that says, like in the previous video, or we would say the molecular weight equals 12. Now, something you should know is that protons give an element its identity. Let me explain. So this is how bromine looks on your periodic table. This number up here is the atomic number. And the atomic number for an atom is equal to the number of protons it has. Everything with 35 protons is bromine, and all bromines have 35 protons. If it has 34 protons, not bromine. What we see here is the atomic mass. And the atomic mass equals the number of protons plus the number of neutrons. What you're seeing on the periodic table, though, is a weighted average of protons and neutrons. Bromine actually has 2 common isotopes. If I wanted to show you the isotope notation of these two, the symbol for bromine is Br. Atomic number goes here, mass number goes there. The other isotope of bromine is bromine 81. So some of the bromines in the world are 79 and some are 81. What we're seeing on the periodic table is an average. So if I average all the 79s and all the 81s together, the average comes out at about 80, really just a little less than 80, because these guys are slightly more abundant than the other ones, thus bringing the average down a little bit. Now, something I'm going to ask you to do is to figure out how many protons and neutrons and electrons something has. So this is an example of an isotope notation for copper. I might also give you just this for copper and not tell you copper 29, because all coppers are 29, so it's sort of redundant. But from this, I know that copper has 29 protons. This particular isotope of copper, 63, is the protons plus the neutrons. So if I were to subtract 29 from 63, I'd get 34, and I would know that this has 34 neutrons. To decide the number of electrons, the number of electrons is the same as the number of protons, unless the atom has a charge on it. And since I didn't write a charge here, we can assume that the atom is uncharged, and it's uncharged because the protons and electrons are the same. Okay, a simple type of problem I might ask of you is to find the number of protons, neutrons, and electrons in a given compound. So let's start here with phosphorus. On your periodic table, the molecular weight of phosphorus rounds to about 31. The number of protons is the atomic number. The mass is the protons plus the neutrons, so 31 minus 15 tells me that this has 16 neutrons. Next, I'm going to figure out the number of electrons. The number of electrons is the same as the number of protons, unless the atom is charged. This atom of phosphorus has a charge of -3. That means it has 3 extra electrons, meaning it has 3 more negatives than it does positives. Therefore, the number of electrons in this would be 18. Okay, let's take a look at the next one. Copper has 29 protons. That's its atomic number. This isotope of copper is 65. So 65 minus 29 gives me 36 neutrons. Next, I want to look for the number of electrons. This isotope, and in this ion form, has 2 more positives than it does negatives. And the electrons are what leaves. Electrons can be gained and lost, and the atom doesn't change its identity. Electrons are on the outside of the atom, so it makes more sense for electrons to come and go than it does for protons that are in the nucleus. If this has a charge of positive 2, it must have 2 more positives than it does negatives. So the number of electrons must be 2 less than the number of protons. Do not change the number of protons. If I change the number of protons, it's not copper anymore. Another notation that you see here is carbon 14. I could also write this as that. So it's telling me the particular isotope of carbon that has a mass of 14. Carbon has 6 protons. This carbon has a mass of 14, which means it has 8 neutrons. I assume that the electrons are the same as the protons unless I'm told that it has a charge, and nobody told me that this was a charged carbon. So now we have one table for you to try to fill out.